Hey guys, this is Coach Player, and today's lesson is 1.3, solving equations with variables on both sides. All right, so let's start off by looking at our learning target. All right, our learning target says I can solve an equation that has variables on both sides using distribution. Right, so that's putting together what we have practiced using some distribution and using it to solve equations. And this is a little bit longer than the last lesson, 1.2, when we were just solving two-step equations. This might mean we have to distribute before, and then variables on both sides means that we're going to have to combine some variable terms as well. All right, let's look at the success criteria. I can distribute, I can combine like terms, right? And then I can utilize inverse operations. We're going to look at what each of those things means. Okay, in lesson 1.1, we practiced distributing and combining like terms. So hopefully you feel confident in those already. And if you don't, that's okay. We're going to try to make sure that you feel confident in that now. All right, and then utilizing inverse operations. You've seen this before, but can we really put it into practice? And can we do it when there is more at stake than just a two-step equation? All right, so to start off, let's look at how are these two equations different. On the left, I have 2 parentheses x plus 5, close parentheses, equals 7. And on the right, I have 6x plus 1 equals 2x minus 3. Okay, so what do you notice is the difference? Well, I notice, for one, that on my left side of the equation, I only have one term on the right side. Okay, where over here, I have 2 terms. And I have 2 terms over here. I also notice that in my left equation, I have to distribute. Right there, right? We're going to distribute that too. Okay, and on the right-hand side, I notice that I have an x on each side. That's what we mean when we say variables on both sides, right? We have an x on each side of the equation, and in order to solve for the variable, in this case x, I can only have one grouping. So I'm going to have to combine my like terms to get only one set of x, right? The simplest form of x so that I can solve for x. Right, so let's just do this by some practicing here. Let's look at number 1. Number 1, I notice, is quite like the example that we just looked at on the right-hand side, right? I have 2 terms and 2 terms and no distribution that I have to do. So the first thing I want to do when I am solving is I want to draw a line down my equal sign. Okay, this just helps me separate my 2 sides of the equation and make sure that I don't forget any steps. Okay. The next thing I want to do is I want to combine my variables first, because that is my end goal, to get only one grouping of y in this case. I'm going to start with that. And the way I like to start with that is I like to look for my smallest coefficient. Okay, I'm looking for my smallest coefficient because this is going to make it a little bit easier when I'm finished. I won't end up with a negative coefficient and dividing by a negative number. I know lots of you probably don't like negative numbers that much, and so this kind of just helps with that. So I'm looking for my coefficient. I'm looking for the smallest coefficient, keeping in mind that it may be a negative coefficient. Okay, so right now I'm looking at my coefficients, and I see that I have no number in front of my y here, and then on the other side I have a 3. Okay, remember when we have no number, that means it's a 1. So my coefficients are 1 and 3. The smallest one is 1. So I'm going to identify that coefficient, that variable, and I am going to apply the inverse operation, okay, so that I can combine my like terms. So for 1y, in order to make that a 0 pair, which means it is, when you add it together, it makes 0, you must complete the inverse operation. Since it's a positive 1y, I'm going to subtract 1y. Or add a negative 1y to both sides. Okay, if I do this to both sides, I'm not changing the equation at all. So this is just like we did with two-step equations, but we're doing it with a variable now instead of just the constant. So I'm always adding the inverse operation. If it's a positive number up top that we're starting with, then we're going to subtract. If it is a negative number, then we're going to add. Okay, I'm going to go ahead and draw a line just so I can see clearly what's happening. I'm not going to worry about my 3 and my negative 1 right now. And I'm going to just kind of do some math now. So 1y minus 1y is 0. Now, we don't have to put that, okay? If it's 0, we don't have to put it. I'm going to put 0 there just so you can get a good picture of what's happening. And then I'm just going to carry my 3 down. So I'm just going to write plus 3. Okay, I'm going to put an equal sign there, and then I'm going to look at 3y minus 1y. 3y minus 1y is 2y. And then again, I'm going to bring down my negative 1. So now I'm left with 3 equals 2y minus 1. Remember, I told you didn't have to say the 0. Okay, oh, look, this looks like a two-step equation to me now. Now all I have to do is combine my constants and then divide by my coefficient. Okay, I want to make sure now that I move the constant away from my term. So the side of the equation, which is my right side, that has the variable, right, is the side that I want to move away. So I'm going to, again, add the inverse operation of the term I would like to make 0 to both sides. So I'm going to add 1 to both sides. This means that when I do my addition here, and I like to cross it out as I'm done, negative 1 plus 1 is 0. So they are gone. That is my goal, to get y by itself. Now I have 2y, and it equals 3 plus 1 is 4. Last step, divide by my coefficient to get 1y. So I'm going to divide both sides by 2, right? You only divide by the coefficient, because 2 divided by 2 is just 1. So I'm left with 1y equals 4 divided by 2 is 2. So there we have it. There is your final answer. Okay, well, let's look at one that's a little bit trickier. All right, this one has some distribution and some combining like terms that we have to do first. Again, I'm going to start off by drawing that line all the way down, and then I'm going to start by looking at the left side of my equation. Right off the bat, I see m minus 2m. Well, I know those are like terms, so I'm going to go ahead and combine those. What is m minus 2m? Well, I think it's negative 1m, and I'm just going to write negative m. All right, and then I don't have anything to combine with the 5, so I'm just going to carry down my plus 5. And then I'm going to say it's equal to, oh, on the right side, it looks like I'm having to distribute because I see parentheses. So I'm going to distribute this. Ooh, that's a tricky one. The negative is way out there, but I'm going to distribute a negative 1 to m and to negative 3. Okay, I'm remembering to distribute to the entire term. So negative 1 times m is negative m, or negative 1m. Negative 1 times negative 3 is positive 3. Now that I have that, I still have terms on both sides, so I'm going to have to combine my like terms. In this case, I notice that both of my coefficients are negative 1. So I am going to have to just pick which side I want to add to. Okay, so it doesn't really matter in this case since it's the same. So I'm going to add an m to both sides of my equation. When I do that, I end up with 2 zero pairs. Right, negative m plus m is 0, so I'm just left with 5. And negative m plus m is also 0, so I'm just left with positive 3. Okay, but 5 doesn't equal 3. What does that mean? This means that I have no solutions because 5 doesn't equal 3. So m is not equal to anything. So I can put my answer as no solution. Sometimes that happens. Okay, let's look at number 3. Number 3 asks us to start off with some distributing. So again, I'm going to draw a line all the way down, and then I'm going to distribute. That means I'm going to multiply the number outside by the terms inside. So I get 5k minus 15, because I remembered to multiply times the entire term, equals negative 2 times k, and negative 2 times 4. So negative 2k minus 8. Don't forget to distribute by that entire value, which is negative 2. Then I'm going to look for my smallest coefficient. My coefficients in this case are 5 and negative 2. Which one's smaller? Negative 2. So I'm going to add the inverse, okay, of the term. So I'm going to do the inverse operation and add the opposite to each side. When I do that, 5k plus 2k is 7k. So 7k minus 15 equals, that makes 0, negative 8. Don't forget to carry down that negative right there. All right, now I just need to move my constant away from my term, from my variable. So I'm going to move away from 7k. So I'm going to add the inverse to both sides. Remember, I can still only combine like terms. I can't combine a k with a constant still. All right, I'm only looking to combine like terms. Bring down my 7k because I didn't do anything different to it. Negative 15 plus 15 is 0. 7k equals negative 8 plus 15, 7. Okay, now I just need to divide by my coefficient, which is 7. So I'm going to divide both sides by 7. When I do that, I get k equals 1.